Students, can you see the file that I've shared with you?
Yes, ma'am.
Yes, ma'am.
Okay. So today we'll be doing two experiments. One is your shear test and the other one will be your compression test. Okay. So quickly, can somebody tell me what did we do in the, sorry, today we'll be doing shear and tensile. Can somebody tell me what did we do in the compression test in the last class? Can somebody give me kind of a review of what was done in the compression test? Is it so difficult? Bhavna? Karthik? Shashank? Boys, can you hear me? Boys? Am I audible?
Yes, ma'am.
So you all don't remember what was done in the last class.
Ma'am, I was absent.
Okay. So the others, you all don't want to tell, or you just want to, being quiet doesn't serve any purpose. You all remember, you all don't remember. I have only 7 students and nobody's. Just take out your manual and see, cross check what was done in the compression test and give me a review now. Quickly. Yes, everybody, I want you to look.
We found the compressive strength of the sand, ma'am.
What was the procedure for it?
It was carried out in a two-way.
Okay.
In first case, the clay percentage is varied and the water percentage is kept constant.
Okay.
And in second case, water percentage is varied and the clay percentage is kept constant.
Okay. Then what do? You prepare the sample.
And we mix the sand and clay thoroughly.
Okay.
And calculate the quantity of water added.
Okay. Then
And
you bring all
the weight of the sand
together. Then you, after bringing them all together, you measure the known weight of the sand. Then you place them on the Ramer specimen. After placing this sample on the Ramer specimen, then what do? We ram the sand. How many times we need to ram the sand? How many times we need to ram the sand? You all don't remember. You need to ram it
thrice.
Okay. Now after the third time, if the top weight exactly lies at the center, that means your sample is acceptable. If it slightly lies above the level also, you need to discard the sand and remake your sample. If it is below also, you need to discard the sand and remake your sample. After that, take this sample remove the sample from the stripper, place it on your universal testing machine. Before that, you need to check whether the compression shackles is fixed on the UTM. Then you place the sample and apply the hydraulic pressure. After applying the hydraulic pressure, slowly the sample have a tendency to break down. The moment it breaks down, you need to note down the value from the from the indicator which is fixed onto the system. Is it clear? So with the same thing, we are going to see how shear test is being done. Boys, you have any doubts in the compression test? At least by now? Brijesh? So if you don't answer when I call out, no attendance will be given. Brijesh? Lalit?
Yes, ma'am.
Lalit, do you have any doubts?
No, ma'am. No doubts, ma'am.
Lalit?
Yes, ma'am. No doubts, ma'am.
What about Shashank?
Yes, ma'am.
Shashank? Doubts?
No, ma'am.
Karthik DB?
No, ma'am.
The other two people? Banu Shakkar?
No, ma'am.
What about Chetan Kumar?
No, ma'am. Not.
Okay. So today we will see the experiment to conduct the shear test. Okay. In shear strength test, basically our aim of the experiment will be to determine the shear strength of the foundry sand sample containing different amounts of sand, clay, moisture. Okay. For this, the apparatus is also measuring jar, AFS rammer, specimen tube, universal sand testing machine, digital balance, and the shear shackles. Now the material used will be paste sand, clay, and water. Right? Shear strength is basically that how much of the sand particles can resist the shear force and retain its shape. Right? So that's the property of the shear strength. In the procedure, you're going to conduct the experiment in two stages. In the first case, the clay percentage will be varied and the water percentage will be kept constant. And in the second case, the water percentage will be varied and clay percentage will be kept constant. Is it clear? After that, the weight quantity of the sand and clay mixture is going to be mixed thoroughly. To do this mixture, calculated amount of water will be added and will be mewed through to get a homogeneous mixture. Then you need to weigh 160 to 200 grams of this sand sample. Then you need to ram it in the AFS rammer 3 times like the conditions before. If it is above the limit, then you need to discard the sample. If it lies below the limit, you need to discard the sample. But if it lies within the tolerance limit, you want to accept it, and then it should be the standard specifications or dimensions required for the shear experiment will be the diameter should be 50 and the height should be 5.08 centimeters. Right? This specimen will be prepared to according to the stripper that we use. Right? Then the moment from the stripper, you remove your sand sample, then take it to your UTM machine, then apply hydraulic pressure continuously till you apply the specific brakes. Then use the dial indicator for taking down your values. Right? Like this, for similar for various percentages, you're going to prepare the specimen. You keep ramming it and take it to your UTM and take all the values. After taking down the values, we're going to plot the graph, that is the shear strength on the y-axis and percentage of moisture on the x-axis. Similarly, we're going to plot one more graph, shear strength on the y-axis and percentage of clay on the x-axis. Now the table will be something like this. Right? The percentage of sand, percentage of clay, water percentage, and from the UTM you'll measure your shear strength. Right? So in this case, the water percentage is constant. Suppose if I take it as 10 ml, right? If 10 ml is the sand, then you need to calculate how much will be the percentage of sand, a percentage of clay. We are going to vary it in 4, 5, 6, whatever ranges they have given. Based on that, you're going to vary the clay. If 5% is water, and 4, 5, 6 is the clay percentage. So remaining percentage will be sand. You need to calculate that, and based on these calculations, these on percentages, you need to prepare your sample, and for every sample you need to find out what will be your shear strength. First, after preparing, bringing all three together, you need to ram it. After ramming it, remove it from the rammer by using a stripper, then place it on the UTM to get your shear strength value. We'll repeat the same thing for the clay percentage constant as well. In this, water percentage will be 4, 5, 6, but clay percentage will be 5% fixed or something like that. Then based on that, you're going to calculate your percentage of sand, and then you will calculate your shear strength. Any doubts here? Any doubts here? Was there any doubts here? So you all have no doubts? Looks like all are sleeping. Chetan, Panu Shankar. No doubts? Ashit,
No, I'm not out.
Shashank,
Yeah.
any doubts here?
Uh,
Okay, so with this, we will see how is the shear strength shackles appear. Okay. See, this is how your shear strength shackles will be there. Can you see at the center line, there will be a groove which has been present here, right? On both top sides, two grooves will be produced, will be seen. And this is how your shear strength shackles will look like. Has it registered in your mind? People see for, well, let it be shear strength or let it be compression test. For both, the procedure will remain the same. I'm playing the video. Kindly have a look at the video. This is the rammer. This is the stripper. This is the stripper. These are your compression shackles. It has 3 grooves. It has 2. But in shear strength, only 2 will be there. UTM. Then the known quantity of sand is placed here, clay is here, and weighing balance. Calculate percentage of sand is added, clay is added. quantity of water is added here. With the shear strength, how much you need to weigh and take it? 162. How many grams? 160 to 200 grams. You need to take the sample. Now using the rammer, you will one, two, three. Using the stipple, you will remove the specimen. Okay. This is the compression test specimen, but for the other one, you will prepare the frame and place it in between the. These are the compression shackles, but you need to place your shear strength shackles, which I showed you earlier. And same thing, you have to place it here. Going to apply pressure until it cracks down. Now, well, if you have no doubts with the shear test, I want to move on with tensile test. Shall we move on?
No, ma'am.
No, ma'am.
No doubts, ma'am.
No doubts. Okay. So in today's class, we'll see what is tensile test as well. So basically, here also the experiment, the baseline will remain the same, but except we will be using an oven to bake the sample. Okay, so in this you need to determine the shear tensile strength of the foundry core sample, which is bonded with a core oil binder. Then apparatus is split core box, sand rammer, oven, tensile shackles, universal testing machine. Material used base sand and core oil. Theory is you need to bring all the materials, bind it, and basically we're going to study the tensile test of the sample, and that you can study basically once when you bake it in the oven at 250 degrees Celsius. This baking will depend upon what kind of composition we are taking, right? So basically now that to see the experiment part, procedure will be weigh the calculated quantity of sand, okay, and mix them thoroughly. In this also you can do the experiment in two things. One, sand percentage will be kept constant and the percentage of binder is varied. The other version is also possible, but we are sticking on to this experiment in which sand percentage will be kept constant and the percentage of binder is varied. The mixed sand is then transferred to the core box assembly. For like, how, don't assume the moment I say core box, don't think that the big core box which we show you, it will be a small core box which takes the sample, which takes the shape of the shear tensile sample, right? So you put it there, right? The moment you put it there, you're going to ram it in the rammer, right? So after it has been gone through the ramming process, the top surface of the specimen will be cleaned and the core box will be removed. Then this specimen remains the plate, and then you're going to take this plate along with the specimen and place it in the oven for about 30 minutes under a temperature of 250 degrees Celsius. Then once when it reaches 250 degrees Celsius and after 30 minutes, you're going to remove the sample from the furnace and allow it to cool to room temperature. After it has been cooled to room temperature, you will take it to the UTM. Then you will fix your tensile test shackles on the UTM. Then apply the hydraulic pressure. The moment it cracks down, you're going to take the readings from the indicator. Is it clear? So here also you have percentage of sand, percentage of binder, and you're going to take down the tensile strength values here. Basically, you're going to plot a graph versus tensile strength and the percentage binder. So now we will see a video on the tensile strength. Can you see this? Can you see the video? How to test a tensile strength of the sand specimen?
Yes, ma'am.
See, this is how the core box also will be of the same shape. Okay, a plate line will be produced after you have made the sample. After you have rammed, you will put it into this kind of a structure which consists of this kind of a shape, the core sample, and allow it to bake in the oven for at 250 degrees Celsius for about 30 minutes. After that, you're going to place your sample here. This is your tensile strength shackles. This is how your tensile strength attachment looks like. Have you made a clear notice? Boys?
Yes, ma'am.
This is your sample. Set the instrument at 0. Can you see the fracture? Did you observe the fracture point? Please observe here. I'm playing the video one more time. Please have a look at it. Do you all may have any doubts here? Now I want you to complete your records. I'll be posting the values for the shear test, plot the graph, and take down these values. After taking down these values, I want you to write your record for both for the tensile strength and for the shear strength. I want you to write the record, plot the graph, and keep your records ready. Is it clear?
Yes, ma'am.
Is there any other doubts? After you all post your graph, maybe all the students can plot the graph, show it to me, and then we can wind up. I want you to quickly plot the graphs. The moment you have plotted the graphs, you can come online and show it to me, and then we can wind up. I want you to observe the graph. Is it clear for everybody? Come on, all of you plot your graph.
Yes, ma'am.
Okay.
Ma'am,
Yes.
ma'am, can you show us the values, ma'am?
Well, is it being shared?
Yes, ma'am. Now it's being shared.
Okay. Boys, did you complete your craft work? Abhishek, can you come online and show me your graph sheet?
Ma'am, just 2 minutes, ma'am. I'm doing the second graph, ma'am.
Okay.
In 2 minutes, sir.
Okay. Anybody who's completed? Karthik, you've done? Want to come online and show? Voice finished? Is it done? Bhavna, Bhanushankar, Lalit,
Yes, ma'am.
can you come online? Show me a graph.
Done, ma'am.
Yes, Bhavna. Good.
Ashit.
Who is it? Ashik.
Ma'am, I'm using my laptop.
So what? If you just can come online and show it.
Yes, ma'am.
Have you switched on your camera?
No, ma'am, one second. Ma'am.
Ma'am, I also finished, ma'am. Abhishek.
Because I think this is creating maybe the camera network problem. I cannot find. Abhishek, have you switched on your camera?
Ma'am.
Yes, very good. Yeah, good job. What about others?
Ma'am. Ma'am.
Because one thing what I'll do is you can post all your graph sheets in today's classroom. In another, I'll give you time till 3:15. You can post it in your classroom, okay, in the Google Classroom.
Ma'am.
I'm finding it difficult for you in bringing you online and checking your graphs. So it's better you post it in the classroom. Okay? Yes, I heard somebody saying, Chetan, have you done?
Yes, ma'am.
No, the point is some values, some people, when the moment I click, it's not linking.
Okay.
I think the better idea will be you all post it in your classroom. Okay?
Okay, ma'am.
Okay, then. Thank you. People who are there in this list, all of you have given the attendance. Okay? Okay, then. Thank you.